Topic 13 covers common fractions. This video is an introductory, so it's about understanding common fractions. Common fraction is a fraction in the form of one integer divided by another integer, which cannot be 0. So a over b will be an example of a common fraction because we have one integer. The integer is numbers, all our positive numbers, 0, all our negative numbers without the comma. Those are our integers. So -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, etc. are integers. So we have an integer at the top, we have an integer at the bottom. In other words, we are dividing by integer, and this integer at the bottom may not be equal to 0, as we cannot divide by 0. It's impossible to share something with nobody. So now we have our definition of a common fraction. So examples would be 5 over 6, -3 over 2, etc. The numerator is the whole number above the fraction line. So it's the top part. So where we showed a, b as a fraction, the top part is the numerator. So if we have, like, for example, 5 over 6 as a fraction, the 5 will be the numerator. The denominator is the whole number below the fraction line. So in our a over b as a fraction, the b portion is the denominator. So if we go back to our fraction of 5 over 6, then the 6 will in fact be the denominator. So numerator on top, denominator at the bottom. Equivalent fractions are fractions with the same value. So for example, if we use 5 over 6 as a fraction, an equivalent fraction will equal that one. So if we multiply, for example, the top by 2 and get 10, and multiply the bottom by 2 to get 12, 5, 6 and 10 over 12 is the same thing. They have the same value. So they are what we refer to as equivalent fractions. Similarly, if we say triple this 10 to 30 and triple the 12 to 36, that would also be equivalent. So all these fractions have the same value. Proper fraction, a common fraction with the denominator bigger than the numerator. So if we go back to a over b, we know the numerator is at the top. Now this denominator at the bottom is bigger than the top. So if b is greater than a, then we have a proper fraction. Another way to put it obviously is to say a is smaller than b. So 5 over 6 is in fact a proper fraction because the top portion is smaller than the bottom portion. Similarly, 3 over 4 would be a proper fraction as the top is smaller than the bottom. So 7 over 3 is not a proper fraction because the top, the numerator, is bigger than the denominator. An improper fraction common fraction with the denominator smaller than the numerator. So it's now just the opposite way around. So 7 over 3 is, for example, an improper fraction because the numerator is bigger than the denominator. Similarly, 5 over 2 will be improper fraction because the top portion, numerator, larger than the bottom portion, the denominator. But 4 over 5 will not be an improper fraction as the numerator is smaller than the denominator. A mixed number is a number that's consisting of a whole number and a fraction. So like 1 3/4 is a mixed number. It has the whole number and it has the fraction. 5 2/3 is another example of a mixed number as it has the whole number and the fraction. But something like 2/5 is not a mixed number as there is no whole number, it's only the fraction. So now that we have focused on some theory, let's attempt the activity. So exercise 13.1, we need to simplify these fractions. So when we simplify fractions, we need it in the simplest form. So we need to see what can go into the numerator as well as in the denominator. There are actually quite a few ways of doing this. The one is actually just to get the prime factors on top and the prime factors at the bottom, and then cancel. So if I illustrate this, if we go back to prime factors, we know 2 goes into 14 7 times. 2 is a prime factor. 7 is also a prime number, so this will simply be 2 times 7. 28, we know our smallest prime number, namely 2, can go into it 14 times. And from here we know into 14, 2 goes 7. So we can rewrite it as 2 times 2 times 7. 2 times 2 is 4 times 7 gives 28. And now we are allowed to cancel. If we multiply and divide, we are allowed to cancel. So this 2 and this 2 cancel. This 7 and this 7 cancel. So what remains is an invisible 1 over 2. Because we could just as well have written at the top 2 times 7 times 1. Because anything times 1 still stays the same. 5 times 1 is 5. 8 times 1 is 8. 7 times 1 is 7. So multiplying by 1 doesn't change the value. So we still have that invisible 1 here that we now explicitly have written. So yeah, the other way that you could do it is just to ask what can go into 28 that can also go into 40 without remainder. Well, we know 14 can go into itself once, 14 can go into 28 twice. So going to give you the opportunity to try number B on your own. See if you can simplify that by either using prime factors or by asking yourself what can go into 125. It can also go into 1000 without remainder. Okay, so 125, I believe, can actually go into 1,000. Let's test. I believe it's 8. Let's see. 125 times 8. 8 times 5 is 40. 2 times 8 is 16 plus 4 is 20. 1 times 8 is 8 plus 2 is 10,000. Yes. So 125 divided by itself is 1. And then 125 we just showed goes 8 times into 1,000. So 1 over 8 is the answer in simplest form. You should get to the same answer if you use the factor tree. So you could have said like 1 to 5. We know 5 is a prime factor. 5 can go into 12 2 times. Remainder 2. 5 goes into 25 5 times. 5 times 5 gives 25. So we have on the top 5 times 5 times 5. For 1,000, we know 2 goes 500 times. We know in 500, 2 goes 250. We know in 250, 2 goes 125. We know in 125, 5 goes 25. We know in 25, 5 goes 5. So we have at the bottom 2 times 2 times 2. So it's 1, 2, 3 2s, 1, 2, 3 5s. And now we are allowed to cancel. Since we are multiplying and dividing, 2 times 2 times 2 is 8. We have the invisible 1 at the top, so we get the same answer. So for number 2, we have to convert 44 and a 9, 44 nines into a mixed number. We see it's improper because the top is bigger than the bottom. So the strategy is see how many times the bottom goes in the top. So 9, if we use multiples of 9, we have 9, 18, 27, 36. So 4 times 9 is 36. We still have a remainder of 44 minus 36 is 8. And we still have the 9 at the bottom. So the strategies, see how many times 9 can divide into 44, or the bottom in the top. Write that number down as the whole part. The remainder you write at the top, you always keep the bottom the same. So now for B, we need to convert 133 over 34 into an improper fraction. We see we have the mixed fraction, we have the whole portion and the fraction. So here the strategy is you always take the bottom part, the denominator, and multiply it by the whole part. So 1 times 34 is 34. And then you add the top part, or the numerator. You keep the bottom part, or the denominator. So 1 times 34 is 34. We still have to add 33. It's all over 34. So 34 and 33 is 67 over 34. Now the top is bigger than the bottom, or the numerator than the denominator. So it is in fact improper fraction. Okay, so we said equivalent fractions means they have the same value. So now we need to complete the missing blocks. So we can first look at the one that's over 4. How do we get from 4 to 100? Well, 4 goes into 125 times, or put differently, 100 divided by 4 is 25. So we will therefore have to multiply 25 by 4 to get 100. So what we do on the left, we do on the right. So something times 25 gives 75. Or perhaps it's easier to go the other way around. Instead of multiplying, we have to divide. So 100 divided by 25 give 4. So what is 75 divided by 25? Yes, it's 3. So 75 over 100 is the same as 3 over 4. Similarly, we can ask, how do we get from 100 to 1000? We simply added 1 0. So we multiply it by 10. So what we do at the bottom, we have to do on the top. So 75 times 10 is 750. So 75 over 100 is the same as 3/4 is the same as 750 over 1000. They are all equivalent fractions. So try number B on your own. Going to give you a bit of time. So you basically have to ask yourself, how do you get from 12 to 4? To get from something bigger to smaller, you had to divide. So 12 divided by 4 is 3 times. So if we divide 12 by 3, we get 4. So 12 divided by 3 gives 4. So if we divide the 12 by 3 to get 4, we should do the same thing on the top. We divide the 15 by 3. So what's 15 divided by 3? Yes, it's 5. So it's the same as 5 over 4. Now that we have 5, we want to get to 25. How do we get from 5 to 25? Yes, we multiply by 5. 5 times 5 is 25. So we can also therefore multiply the 4 by 5. And that results in 20. So 15 over 12 is the same as 5 over 4 is the same as 25 over 20. All of them are equivalent fractions. And now we are comparing fractions. So we have to replace the block with the correct relationship, either smaller, bigger than, or equal to. So the strategy here is to get the bottom ones the same. In other words, the denominators. So if we multiply 4 by 4, we will also get 16. So what we do at the bottom, we have to do at the top. So 3 times 4 is 12, 4 times 4 is 16. So now we are comparing 12 over 16 against 11 over 16. So 12 is bigger than 11. So 12 16ths must be bigger than 11 16ths, meaning 3/4 are bigger than 11 16ths, as 3/4 and 12 16ths are equivalent fractions. You know, the bigger than sign, the open mouth points to the bigger side. The small angle point to the smaller side. So I'm going to ask you to try number B. I'm going to give you a bit of time. See if you can find the solution. So the first step is we will have to get the 7 and 5 both equal. But always tend to work is to just multiply those two. Sometimes it gives the big answers. You could get smaller ones by using your logic, but at least this always works. In this case, it will in fact be the best option. It will be the smallest possible answer. So 35, 7 can go into 35 and 5 can go into 35. So how do we get from 7 to 35? We multiply by 5. So we have to multiply the top and the bottom by 5. Oops, not 3. 7 times 5. On the right hand side, we multiply by 7, the top and the bottom. So now we have 15 over 35 in comparison to 7 times 3 is 21 over 35. This time the larger side is on the right hand side. 21 is bigger than 15, so the pointed side point to the smaller side, the open mouth to the bigger side. So in this case 3/7 smaller than 3/5. So now let's look at the word problem. Fahima is given a chocolate slab by her mother. The slab of chocolate is divided into 12 blocks. She gives 9 blocks to her friends and keeps the rest. What fraction of the chocolate slab did Fahima keep? Well, so she has 1 whole chocolate, which is the same as 12 over 12. Of that, because 12 over 12 is 1, that's a whole unit. So from 12 she gives 9 12s to her friends. So 12 minus 9 is 3 12s. So 3 12s is in fact what she have kept, since she gave away 9 12s. To give away means to reduce, means the answer becomes smaller, so that's why we subtract. So that's why we end up with 3 12s. We could simplify, this is not in simplest form. 3 can go into itself, 3 can go into 12. 3 goes into itself once. 3 go how many times into 12? 3, 6, 9, 12, yes, 4 times. So a quarter is what she in fact kept to herself. So I'm going to ask for your task to attempt number 5, which is another word problem.